Good morning, good afternoon, and good evening. Um, my name is Goodness, and I'll be walking us through the second library in data science. We've talked about the Python crash course, and by now I hope we all have a basic knowledge of how to write Python and also the syntax of writing Python. So we'll be working with this library called Numpy. I think it's the first library we'll be working with Numpy. Okay. So basically, I told us um, how to use this environment that we run or we make use of different navigations here. So this is NumPy. We could check out the website for NumPy on that is the official website for NumPy. While it's loading, let me just walk through what NumPy is all about. So NumPy is a library. It's a library used for arithmetic operation, for instance, mathematical operation. For instance, you want to do matrix, you want to do calculations, mathematical related courses. You could use NumPy library as because it has a lot of functions that allow us to perform arithmetic operations. So we could check the website out. I showed us by going to help, and by clicking this, you get to this place. So now over here we have the NumPy with a lot of functions. It's a very broad library, but we're looking at a specific aspect of it. Okay, so you could make reference to this place. You could go to the user guide also. You could go to the user guide and check what NumPy is, the installation. Okay, you could check what it is, its installation, and all that stuff. Okay, so let's just bounce through this Jupyter notebook. Okay, so the first thing we do is to import the NumPy library, and to import the NumPy library, you say import NumPy as np. So, and how do we run this? I said we could use Shift Enter on our keyboard to run, or we could press this play button here to run, or we could press run here to run it. Okay, so now import NumPy as np. Now the function np is what we'll be using throughout. So for example, NumPy has about 5 libraries, functions, or let me say 5 method instead. Okay, so now let's work with, we've talked about a list. We said a list contains different items in it. So now let's consider fob as a list. Now fob is a list that has 4 elements or 4 values in it. And how do you identify a list? A list has a square bracket. Okay, now you say np, that is this stuff which represents NumPy dot array open bracket close bracket fob. Now we've converted this list to an array, converted the list to an array. Now if you see over here, when we run this, we have an array. So array 1, 2, 3. So this is now what is called an array. So now let's look at the second function, which is zeros. So how do you do this? We say np.zeros 5, comma dtype. Dtype is also called data types. And don't forget, when we're doing Python crash course, we talked about the basic data types we have. We said we have integer. So integer represents int. Integer represents int. We have floats, that is decimal numbers, and we have complex numbers. Okay, good. So now let's talk about zeros. Now zeros in the sense that we have 0 in 5 places. So we could put in here 100. When we run this, we have 100 zeros. Okay, or with data type integer, it works with integer. So if I say, when we say 0 plus anything, it gives us that same number. So I'll say 0 plus 10. It's going to give me 10 in 100 places. Okay, or let me change this place to 5. It's going to give me 5 in 10 places. Okay, all these libraries that we're looking at, they use them when they're carrying out arithmetic operations. Probably they want something to be repeated in a specific number of times. So that's why we use this library, this function of method np.zeros. Now let's consider np.ones. Same thing applies here. But in this case, we're not using addition. No, anything multiplied by 1 is that same number. Okay, so let's delete this for now and let's change this. So now we have np.ones. Now we have ones in how many places? 100 places. Let me change this place to 5. np.zeros, open bracket, close bracket, 5 comma data type int. We have 1 in 5 places, and I told us that 1 times anything gives us that same thing. So we say 1 times 100, hit enter, it's going to give us 100 in 5 places. Okay, so we could do the same thing for a matrix. Don't forget, this is a matrix, that is a two-dimensional matrix. How is it a two-dimensional matrix? Because of these last 2 columns here. So that's how we identify the two-dimensional matrix. And let's look at this. np.ones, right? 5 comma 10, that is 5 rows, 2 columns. Okay, and with a data type of int. Okay, we could do shift tab to see the signature in it. That is, for example, you see by default the data type is none. Okay, by default data type is none. Okay, but when we specify int, now let me try if floats. Let me run this. Now I change data type to floats. Can you see now it's 2 points? Can you see now it's 2 point something? Let me change it to 25. Let's see. Now we have 25 point something. Now data type is float. Let me change it back to int. Run it. So now we have our data type. I don't know the difference between integer, that is int or integer, and float. Said integer are whole numbers, while floats are decimal numbers. That is 3 point something, 5 point something, and so on. Now, hope you understand this part. Now let's move to full. Full. Full is another method in Numpy as a library that allows us to do a matrix format. For example, we have D equals to np.full 4 by 4 matrix, that is 4 rows and 4 columns. We have 4 rows, 1, 2, 3, 4. And how many columns? 1, 2, 3, 4. That's 4 columns. Okay, now this last one is the value outside, that is the output. I told us don't forget that it's always good to comment, so when next you are going through your code, you could understand what it is. Okay, so rows 4, column 4, output 10, data type floats. So data type integer. You could change this to float. You can't type, if you type in integer, full like this, it's going to give you an error. We could type float. Sorry, type floats. You type integer, int like this, in full. Okay, now let's talk about. Okay, so you could type integer in full, or you could type floats. Okay, and if you type in float, you have it in decimal. Okay, so let's change it back to int. Right, we could change this also to 3. So we have 4 by 3 matrix. Okay, that's 4 rows to 3 columns. Now let's look at another one. We could also say x equals to np.full 3 comma 2. That is 3 columns, 3 rows, 5 and 2 columns. Let me come again. 3 rows, 2 columns. That is row 1, row 2, row 3. Then columns, this 2, 1, 2. Okay, now we have np.eyes. np.eyes is for identity matrix. That is all diagonals that are always 1. For example, let's look at 5. If we do 5 by 3 matrix, don't forget this is a two-dimensional matrix. It's going to give us all diagonals 1. Let's change it to 5 by 5 matrix. So let's see. See now all the diagonals are 1 each of them, and by default the data type is data type is floats. Let's change to int. Let's see. Okay, I'm missing a comma here. Okay, so now by default it is float, but now it's changed to int. So if I remove this, if I cut this out and run this, I have it like this. Now let's talk about properties of an array. Now in array we have don't forget this is D. Let me run this. You could do alt enter to create a cell below this, alt enter, okay, like alt plus enter key. Okay, you could press this on your keyboard to run a cell like this. Okay, this is going to give me an error currently because this is in code. I could change it to markdown if I want to, but I'm not changing to markdown. I'm changing back to code. Okay, so let me delete this. In this place, this is blue. This is blue. This is green. See, the color of the cell is green. Color of cell is blue. Color of cell is green. If I click here, it's blue. If I click here, it's green. If I click here, it's blue. And if I do DD, it's going to delete the cell. Okay. So now let's print D. If I run this, I have D. So D is it's 4 by 3 matrix. How is it 4 by 3 matrix? This is 1, 2, 3, 4, and this is 1, 2, 3. So this is we had a comment 4 by 3 matrix. Okay, so now how do we now get the dimension? We say n dash d dot n dim, that is get the size of dimension, that is 2. Okay, don't forget I told you it's a 2-dimensional matrix. But how do you identify a 2-dimensional matrix? By this square bracket at the end of it. It's a 2-dimensional matrix. Now when I say d dot shape, what does it mean? What does it mean? Sorry, d dot shape, what does it mean? That is the shape of the matrix. Now I told us it was 4 by 3 matrix, and this is it, 4 by 3 matrix. The reason why it was 4,4 was because I ran it before, but I just rerun it again. That's why I'm having 4 by 3 matrix. You could run it again. I changed the value of D. Where's D up over here? I changed the value of D from 4 by 4. It was 4 by 4 initially, but I changed it to 4 by 3. So if you come down here and run it, you will have the same thing. So we have D dot size. When you talk about size, that is the size of the matrix. That is everything in here now is 12. That is 3 times 4, 12. Okay. Then when you talk about the D type, we said it is int 32. That is integer. If you come in here, that is where is D. Let's come to D and change it. Let's change the space to float. Okay, let's run it. We have it in float, right? So let's go and run everything. Can you see the data type here has changed to floats? Okay, so let's just understand that aspect. Now let's talk about linked space. Linked space is like range. Okay, so for example, this gives us a linked space of 2 to 20. That is, gives us a range of 2 to 20, but a specific size of 6 elements. Okay, I could change this to 10. Now I have a size of 10. That is, it's going to generate it's going to generate numbers from 2 to 20 for me with a size of 10. Okay, I could specify it to 11 and to give me 11. Okay, so that's how it works. Now let's talk about NumPy indexing and selection. Okay, so now we're talking about the last function or method in NumPy that we'll talk, that is from this place. Okay, so we're talking about we're looking at arrange. That's arrange. Arrange. I call it arrange, but it's arrange though. Anyhow you call it is fine. So np dot arrange, that is 1, 20. That is, don't forget we talked about range in the in Python crash course where we say if you have to find the range of something, you have to subtract it by 1, right? Why? Because yeah, the indexing starts from 0. So now let's run this. We have 1 to 19. It will give you the exact end of the range. Okay. So now let's talk about. Now let's do this. We said A. Don't forget this A that is arrange. It means array of range. That is, give me an array of range. Okay. How do you identify an array? An array always starts with like to tell you array, then open bracket, close open bracket, parentheses, then square bracket. That's how you identify a normal array. Like if something is an array, don't forget, see, for example, this is an array. This is an array, right? This is an array. It always starts with this array word keyword array. Okay, so now let's move on. So now when I talk about array of 0 to 11, it's going to give me 0 to what? 10. Okay, let me run this for us to see. We will click here to run. Now, don't forget when I said we have what they call indexing, right? Okay, let me copy this. I told us about Alt Enter, right? So I could create a new cell below. So I created a new cell below. Okay, I'll change this cell to a markdown so that my interpreter will not be able to recognize it. Okay, so I'm going to come over here and comment this and say 0, sorry, say 0, just copy what is here actually and paste it up here. Okay, I hope you get it. Okay, I could just paste it. So if I say this is the index, let me just put it like this. So this is the index, right? If I say give me the index of, don't forget we talked about index. We said index are used to access a value or an item. Okay, so now I want to access this 8 here. What do I say? I say ARR of 8. ARR of 8 to give me 8. Or if I say ARR of 0, ARR of 0 will give me 0. That is, I want to get it 0, I'm going to get this. Okay, what if we say let this be from 1 to 11? I want to change the question now. 1 to 11. Now I have my output as this, so I'm going to change this. All together, good. I hope we are all following because it's okay. 9, 10. So I'm going to add in 11. Okay. So when I run this, so I have this right now. If I want to access the item 8, what's it going to be? Index of 7. So if I say 7, I have 8. Or if I say 9, if I say 8 itself, I have 9. It's the index of 9 will give me 10. So let's try it. If I change this to 9, it gives me 10. Okay, if I change this to 10, it gives me 11. Okay, 0 to 10. Okay, I'm going outside the what's it called? Yeah, I put in 10 here, but there's nothing like 10 altogether. I was on added this. Let me explain this so we could get again. Okay, so this is the array, that is array of 1 to 11. Array of 1 to 11 is going to give us 1 to 10. Cleared? Yes, understood. Then I copied it, I pasted it here. Now the index for each of these values, these are the values. Consider this as values. Let me put in hashtag here so we could understand. Consider this as value. Consider this as value. Okay. Consider this as value. Okay. Consider this as value. okay, and consider this as the index, okay. So now I have my value and index as this, and if I say I want to go, index is stopped at 9, but now say I want to go 10 as array of 10, it's going to give me an error because index 10 is out of bound for at the 0 with size 10, okay. So I can't have access to it, but if I say 9, I have access to it, or if I say 0, I have access to it, sorry, 0, I have access to it. If I say -1, I have access to it, 10. Now we'll be talking about negative index, and I think we discussed about negative indexing already. We talked about negative indexing, that is, let me just sharply do that. Index is, this is 0, which is 0. From here we have it as -1, have it as -2, we have it as -3, we have it as 4, we have it as -5, we have it as -6, we have it as -7, we have it as 8, we have it as -9. Okay, -9, 8, sorry, -9, 8, 7, 6, 5, 4, 3, 2,